Okay, so this last one that we're working on, 25.4, weathercasting and weather forecasting. How many of you ever paid attention? You've got Chief Meteorologist Dylan Dreyer, or you've got weathercaster Bob May, right? So what's the difference between weathercaster and meteorologist? There is actually a big difference, and we're going to talk about that. How weather maps are made. It's pretty cool. I've actually spent a lot of time making weather maps with meteorologists down in Lincoln, Illinois, where our National Weather Service is. We'll talk about the National Weather Service a little bit, and then describe the steps in preparing a forecast. That's pretty interesting too. So here's my question for you. First of all, how many people, name me a profession that is not affected by the weather. Go. I got this in one class. I got this one. A coal miner. Right? Underground, right? How'd they get to work? Oh, sorry. I got another one. This was another one that they gave me. A person who works on the International Space Station. How'd they get up there? Oh, what dog? A babysitter. Excuse me, Jimmy. You can't go outside right now, so you're going to have to stay inside. Yeah. So, again, if you think about it, weather affects everyone. And so, getting it right is important. However, if you want a job, think about this. Being a meteorologist or a weathercaster, one of the greatest jobs for job security. Why? Where else can you be wrong 50% of the time and still have a job? Right? And so the reality is forecasting the weather is tricky. Now, it's a lot better than it used to be, right? So what happens is this. Back in the old day, we used to have a thermometer and maybe a barometer or an anemometer, and using the telegraph, which is not used very much anymore, they would tell people what was going on. We saw a big change in the system, though, when the telephone came about, and then all of a sudden we started to see more and more different types of things happening. But in 1970, which happens to be the National Weather Service in the United States was formed. Now, we have a National Weather Service office located in Lincoln, Illinois. It's the coolest place ever, right? How many of you have NOAA weather radios, right? They're part of the National Weather Service, NOAA weather radios. So you get this, and then all of a sudden, okay, the National Weather Service located in Lincoln, Illinois has issued a thunderstorm warning for the following counties: Cass, Logan, DeWitt, McLean, Livingston. And all of a sudden you're like, hey, I better take shelter or whatever. These guys are the ones that are putting out the statements and the weather, right? So every 6 hours they go out and they send up a weather balloon, just like the one that we sent up in my 4th hour class. Just like that one. The one that Grover flew on. And ironically, the weather sonde, or radio sonde that I have, this one right here in my hand, a little bit different than the one they send out. Of course, theirs doesn't have Grover on it. But a little bit different, but the same things are being measured. So the reality is we do the same thing, only they send theirs up every 6 hours. And every 6 hours they go get it. Right? And so not only do they do it, but now they upload that data to the interweb and use computer modeling to determine what's going to happen weather-wise. Interestingly enough, Every day, every 6 hours, they release them, and they get to see what's going on. You ever think about planes? Yeah, they've got to know that they're up there. So then came the World Meteorological Organization. Basically what they are doing is the exact same thing, only globally. They're releasing them in Europe and in Australia and all over the world. And then they're putting that data together. And so now we have this global database of information of weather conditions all around the world happening every 6 hours. So, what do? We take that information and we make what's called a station model. And in the station model gives us symbols that we can put down. It's a circle. And in the circle, it has different symbols that go along the circle that every meteorologist around the world can interpret and understand what's going on. Now, if you look in your book, it's on page 513, there's a station model right there. It tells us the speed of the wind, tells us the percent cloud cover, tells us the relative humidity, temperature, barometric pressure, etc. Tells us all that. And this is used by scientists to make maps. Now, it used to be they had to do it all by hand. Now they have computer models that do it, right? And so, basically, what does it include? All the things that I already talked about. What does the word ISO mean? So, I get isolate, all by yourself. But the word ISO really means same. So when we talk about isobars, isobars means same barometric pressure, or bars. We also have isotherms, same temperature. Okay? So, here's the thing. When we look at a weather map, close to each other, like last night. What happened last night? Anybody know? It did rain. What else happened? Yeah, we had a thunderstorm come through, and the wind was blowing really, really fast. I had a tree that was almost bent over, right? And so our lines last night at our maps were very, very close together. I'll show you an image of it. If they're spaced a long way apart, so example, you can have a isobar being the next closest one is in Iowa. So now you're going, well, what does that really tell me? So just so you know, quickest meteorological tip I'm going to give you all year long, probably the best thing that you'll ever use in your lifetime when it comes to figuring out what the heck is going on with the weather. Ready? High pressure, blue skies, sunshiny day. Low pressure, cloudy, hazy, rainy, precipitation. Just that easy. So you have a bluebird day when it's a high pressure system. And you have not so bluebird day when it's a low pressure system. Just that simple. Right? So now, just like a zit, we go from high pressure to low pressure. And you should be able to determine which way the wind is going just by knowing that. So I'm going to show you what we're talking about. A circle, when there's a circle on the map, it's either high pressure or low pressure. That is the center of that system. So if we look at the map up top, first of all, I can see that I have a warm front right here by Arkansas, Missouri. I have a cold front behind it, and then I have an occluded front up top. All right. So now I have that. So now I'm looking at it going, okay, up at the map up top. If you look, the lines are very close together. Those are isobars. That wind is hauling major booty through there. Right? Down here, you've got one isobar that goes from Nebraska all the way to Colorado. Not only is it not blowing there, it's probably not going to blow there anytime soon. Because the isobar behind it goes all the way back to Washington, state of. So not a lot of wind going on there. And you'll see these circles where the high pressure system, that means everything in that circle, on that circle line, is the same pressure. Again, high pressure, high pressure, high pressure, warm front. The cold front just went through over here on the East Coast, and you can see the lines just off the East Coast where the storms are. Guess what? High wind system. Did it rain last night? Yeah. Did the wind blow last night? Yeah. Guess what? Makes sense. We had a cold front go through last night. Oh, where's the cold front? Over here on the East Coast. By the way, when they show this to you on TV, you should be able to figure out what the heck's going on without them having to tell you if you look at these different symbols. But you wait for Al Roker. Hey, this is what's happening in your neck of the woods. That type thing, right? So, types of forecasts. All right, so I love these. Today, there's a high pressure system coming out of the west. Looks like we're going to have a high of about 85 today. Sunshine. Going to push right through on the weekend. Looks like you guys are going to have a great time. So, again, we get our daily forecast. What's going on? Then we can do our 2-day. 48 hours, right? Extended forecast, usually 5 days. Now listen, I'm going to be real honest with you. I love these television stations, and the 8-day forecast is anything over 7 days, it's like throwing a freaking dart at the wall, right? Here's why. 7 days of forecast is somewhere out in the middle of the Pacific Ocean. Guess what? A lot of moisture, a lot of humidity, sun's beating down, causing things to change real quick. Your guess is as good as anybody else's what's going to happen. So I love that. Now, again, we have long range, monthly, seasonal. I listen to people, well, we're going to have an El Nino year, right? God forbid. We're going to have the Godzilla El Nino. Well, you know, there's a good indication by looking at the water temperatures. They can do that. But they can't tell you whether it's going to rain on June the 7th or not. Right? That they can't do. They can say stuff like, yeah, we're probably going to get greater than average amounts of precipitation. Here's another one. Is anybody familiar with the Farmer's Almanac? Oh, yeah. Yeah. Oh, yeah. Yeah. Right next to the pumpkin pie recipe, they usually have what the month of October is supposed to look like. How did they figure that out? They looked at the last 200 months of October and looked and made a trend. Oh, I see. It should be something like this. Are they going to be right? Maybe. Are they going to be wrong? Maybe. Right? So we can get kind of ballparks. That's like me going to a tarot card reader and they going, hey, you're going to find money. Well, when? How much? Well, if I'm walking down the road, find a penny on the ground, did I find money? Yeah, I found money. Right? And so you can get things so general that the information means absolutely nothing. All right, so a daily and long-term forecast. What do? We plot them out on the map. And then we look at the ones from behind. And then we look at the ones from other places. And it gives us an understanding. What are we doing? We're plotting it. We're looking at satellite. We're looking at radar images. We're being able to create different data with the data that we get from everybody else. What do we do about in the middle of the Pacific Ocean? Say you're in Hawaii. Well, they have beacons and buoys out there too, right? They also are pulling from China and Russia. So, meteorologist, what's different than a meteorologist and a weathercaster? A meteorologist has a degree in meteorology and interprets maps. What's a weathercaster? Someone who interprets and tells you what the weather is going to be. Can they do the same job? Yes. Do they do the same job? Sometimes. Are they the same thing? No. So once the forecast is issued, it goes out on the airwaves. People find out about it. That's when you go, I think I'm going to wear a jacket today. Or, hey, let's break out the bathing suit. Right? So the issue is if it rained like last night and we knew it was going to rain last night, we had an idea, can you determine? No. That's when I call my father-in-law, go, how much rain did you get? And I go, oh, I got 5/10. What'd you get? Oh, I got 1.5 inches. What's the difference? There's a lot, right? And so we're looking at a totally different amount of precipitation. That could mean the difference between whether or not you have a crop and not. So, depending on where you're doing and what you're doing. Now, this is the interesting thing, that controlling the weather. Why would you want to control the weather? Wait, I got it. It's your wedding day. Girls, correct me if I'm wrong. Rain on your wedding day probably is going to put a little dampener on everything. Right? Okay. If you're inside. Yeah. Nice. Right. Yeah. So, here's the interesting thing. What about in farming? Well, gee, I need water on my crops. Well, what if you could control it? There's been a lot of experimentation using seed nuclei, and we're talking about very, very small dust particles and things like that they fly over the top of these clouds, and they lace them with these seeds. And they're not like seeds, like as in like a apple seed or something like that. We're talking about dust particles or particles of something. And so they've played with it. Russia played with it a lot. They got hail. And so caused a lot of problems with that crop when that happened. What could happen if you could stop or prevent a hurricane? Right? So this is a big question. Think about what happened with Katrina and down in New Orleans. What would have happened if you could have slowed it down? And so people have tried with mixed results to slow them down. There's a whole group of people out there, especially conspiracy theorists, who talk about geoengineering and things like that of the planet and our weather systems. And it's really interesting if you ever want to look at it. Problem is, we can't slow them down. We've tried. There is something that's pretty interesting to me, though, is lightning. And what do I mean by that? One of the things that people are trying to do is they're trying to harness lightning bolts. Why? For the energy. One lightning bolt has enough energy to power an entire city. Right? And so, interestingly enough, if we could figure out how to grab one and harness it, the problem is we don't have batteries that take that kind of a charging that quickly, and that's really the big problem with that. But if you ever want to look something up really cool, look up shooting rockets into lightning storms. They have this trailing piece of copper, and it's very thin wire. And what they do is they shoot it up, and when it does, the lightning will travel down the path of the copper. It's crazy cool. And you don't want to be anywhere near it. We've launched a lot of rockets. I'm not talking about like Thomas Edison type stuff or Benjamin Franklin and the kite stuff. I'm talking about you losing your life type stuff, right? And so it's crazy what they're doing. Silver iodide. One of the things that I've seen them try and do is when we are in a drought condition, people think about trying to seed with airplanes silver iodide, which would cause it to rain. No real good results on that either. But here's my question. Let's say Emily wants to have it rain over her field and she gets silver iodide to put in the cloud to rain. 1, does it hit her field? 2, if it hits her field, whose else's field didn't get watered because of Emily doing that? There's a lot of ethical questions there. So, all right. So we said the code word would be what? Yellow polo. So the code word is yellow polo. If you do not have yellow polo on your sheet, then you don't get credit for it. So write yellow polo. Thanks so much for listening, and I hope you guys have a great day.